Good morning. Can you hear me? Can you hear me? Okay. Very happy new year for you all. 2026. I hope you all dreams and achievements you can achieve within this year. And this is very important year for you all because this is actually working time. We have a lot of works in not only our subjects, uh, all subjects. Maximum you can cover within maximum mean actually if you can cover all syllabus within this year, it is very uh, easy to final 6 month. Next year you have only 6 months. Okay, if you can cover maximum 80 to 90% of syllabus, it is very easy for ready for this exam during final 6 months. Okay, I got tute packs. I got tutes. Send me message. Yes, 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 yes. Upsell. It. Upsell. Ahmed, no? Yes, I have posted same day. Okay, check post office. Today, check your post office. No problem. Today we can continue lesson without tute. I will share PDF. Others? Anyone not received yet? Everyone okay, right? Kadma Harner. Kabir Dinul okay. Sadev, I got tute pack. No. If no, you can check your post office. I think post office delay. Three students, no? Three students. Okay, however, I will share the PDF of the PDF. I'll share in the group chat. Easy. You can check. Today is Sunday. Tomorrow morning you can check your post office. Definitely you can get the tube. Sandit, I got Sandit. Yes. Wait, let me share the word, not PDF. Okay, you can download this PDF file, and tomorrow morning you can get the tute back. Okay, download this. Okay, before start the new lesson, we have a small part in the trigonometry lesson, right? You mean we have a small part in trigonometry lesson. Okay, go to the trigonometry, our written note. Trigonometry written note. Okay, what is the final topic? Sumit, Habir, what's the final topic we discussed? Relationships, right? After relationships, we discuss circular bases. Yes, circular bases. Am I correct? Circular base is the final part. And we did calculations. Okay, write down the final topic that we already discussed actually in the paper discussion. The area of triangle, the area of, write down final small topic, the area of any triangle using standard notation method. Using standard notation method. The area of any triangle using standard notation method. The area of any triangle, the area of any triangle using standard notation method. Okay, if you got any type of triangle, right angle triangle or other type triangles, right angle triangle or any triangle, think it is ABC. Now let's take another normal triangle. It's not a triangle. Okay, this type normal triangle. What is the standard notation that we discussed in the first day of the lesson? Okay, what's the meaning of the standard notation? Standard notation is simple standard labeling method. Okay, what's the definition of triangle that we discussed? But we discussed in last year. Last year. Okay, what's the definition of triangle? Triangle is a 2D shape. It's not a 3D, it's a 2D shape, only two-dimensional. It's a 2D shape with three vertex, three angles, and three sides. Okay, they are the main characteristics. Three vertex, three angles, see, three vertex, three angles, and three sides. Three sides. Okay, these components, standard labeling method we called as the standard notation that we already discussed, right? The standard labeling method. Okay, if I think this is P, this vertex capital Q, the above vertex capital R, according to standard notation, you can say this angle capital R same as vertex. PQ R. This angle capital R, this angle same as vertex capital P, this one capital R, it's capital Q, no? Capital Q. capital Q. Okay, now 3 vertex labeled, 3 angles labeled. Now what is remain? 3 sides. 3 sides. How to label 3 sides? Anyone? Do you remember? How to label 3 sides? What's the method? In standard notation? Sandit? Yeah, simple letters. Very good. Simple letters of opposite angle, right? Opposite angle or opposite vertex. Okay, this is the this. If you got this side, this is the opposite angle. It is capital Q. Then this side is simple Q. Simple Q. The below side, opposite side angle is capital R. Therefore, this is simple R. Simple R. Simple R. Simple R. This is opposite side. It is capital P and it is simple. Okay, this is the standard notation for any triangle. Any triangle, this is a standard notation. Standard notation means simply a labeling method. හරිද? මේ විදිහට label කරන standard method. The worldwide standard notation. Standard method. Okay, that is a standard notation. Okay, according to standard notation, I will change into our ABC structure for our easy calculation, for easy understand. Now, I told any capital or simple letters we can use in this standard notation. Okay, I will take it as ABC. Take another type triangle. Okay, this is A, B, C. This is the standard notation: capital A, capital B, capital C, simple C, simple A, simple B. Okay, whatever English capital and simple letters you can use for this standard notation. Okay, now what is the area calculation equation that you already know? What is the area equation? The area of any triangle, you know, in O level time you did half into base into height, no, perpendicular height. The area equal half into base into height. That is a one and only equation you used in O level time for calculate the area of triangle. Okay, but if you if you can't find this perpendicular height, think I don't have any methods to calculate this perpendicular height, then how can calculate the area of triangle? Area of triangle. Okay, this is using trigonometric ratios and standard notation. Using trigonometric ratios and standard notation, we can get a relationship. We can get a relationship for area of any type of triangle using standard notation. Okay, this is a method. Very simply, it is a derivative equation of the same equation. Okay, derived equation. මේකෙම හදපු equation එකක් තමයි. The equation is half into AB sin C. Okay. Okay, I will explain how to derive this equation using our basic equation. Okay, the area equal half into base into height. That is our common equation. Okay, the area. I will mark this side is simple B, correct. It's simple B. This side, I'm going to change A and B for easy understanding. Now correct. Okay, I'm going to make this is the perpendicular height of this triangle. This perpendicular height, this point is I mark as capital D. It's capital D. Okay, it's capital D. Okay, now half is a constant, right? Half is a constant. Half is a constant. Now base, what is the base of this triangle? AC. AC is the base. AC is the base. What is the perpendicular height of this triangle? AD. AD. AD is the perpendicular height. AD is the perpendicular height. Okay. Now, if you, this is perpendicular height. This is perpendicular height. If it is perpendicular to this base, perpendicular to base, this ADC is another triangle, right? And in another right angle triangle. ADB is another right angle triangle. Both right angle triangles because this perpendicular height perpendicular to the base. That's the point. Okay, therefore it is 90 degree and 90 degree. 90 and 90, it is perpendicular to the base. Now, I can get ADC is a right angle triangle. If we consider ADC triangle, ADC triangle, ADC triangle, ADC triangle, sin C equal, sin C. If you use my target is calculate AD using base. Okay, that's why I use using whatever ratio I want to calculate the perpendicular height. Now perpendicular height we can get sin C equal opposite over hypotenuse. No, opposite over hypotenuse. Opposite side is AD. AD is the opposite side. This is AD opposite side. And hypotenuse, it is simple B. No? Simple B, sin C equal opposite over hypotenuse. Sin C equal opposite over hypotenuse. Now my target, what is my target? Calculate AD perpendicular height. Now perpendicular height AD equal cross multiplication. AD equal B sin C. What is it? B sin C. B sin C is the AD. AD is the B sin C. Okay, now I have my first equation. Half AC into AD. But problem, I don't know AD. I don't know AD. Now AD equal B sin C. I got relationship AD equal B sin C. Okay, this is my second equation. AD equal B sin C. AD equal B sin C. Okay, now I'm going to write here the area equal in my, according to my first equation, it is half AC mean what is the side? In simple A, right? This is simple A. AC means simple A. This is my first equation. Instead of AD, I'm going to substitute my second equation. AD equal B sin C, then B sin C. Okay, this is the equation for any type of triangle. Any type of triangle. Understood the method? Any doubt? Observe. Still we are doing trigonometry, okay? Not work and energy. Jumit? මෙයාගේ AD වෙනුවට I substitute B sin C because AD equal to B sin C, right? AD equal to B sin C. මේ AC අපි ගත්ත AC equal to this is A side, simple A side. Vihanga? Understood? Now change වෙලා නේද? සරි. BC into AD, yes. BC into AD. Take it as A, then it is CC. A into AD. Now AD equal B sin C. Now correct, right? Now correct. The base you can directly say it is A. Simple A. Okay, write down clearly. Okay, done. Okay, complete, right? And it is very simple. The area equal half into base into height. Now height I got it is B sin C according to sin C ratio. Okay, AD equal B sin C. Therefore, AD B sin C value I substitute to our common equation into instead of base, no? Sorry, perpendicular height. Base same base into perpendicular height. Okay, now understand if you got this base, now our common equation for any triangle, half into base into, sorry, half into AB sine C. AB sine C. Okay, see, think this according to standard notation. This is the A side. This is the B. This is a C angle. This is a C angle. Remember, if you use this equation, always this consider angle, මෙතන sine විදියට ගන්න angle එක always should be between the two AB sides. That is a rule. That is a rule. Always the two sides, A and B side, between the two sides. That is a condition. That's a condition. Okay, let's do one example. Example number 1. Example number 1. What is the area of this triangle? What's the area of this triangle? Okay, quickly. What is the area of this triangle? Send your answers. Sadev? Yeah. How to get this? We don't know perpendicular height. That's the issue. If you know the perpendicular height, you can say half into base into height, half into base into height. But the problem, you don't know the perpendicular height. You don't know perpendicular height. Okay, how to get this? The area equal half into AB sine C. AB sine C. Half is a constant. AB, A and B always අපි ගන්න ඕනේ between two sides between the angle, between consider angle. එතකොට මෙන්න මේ දෙක තමයි ගන්න ඕනේ. Clear? Then A and B, if it is changed, no problem. Changing, no problem. 5 and 3 change not අවුලක් නැහැ. Multiplication 5 into 3. Sin C means sin 30. The angle between those two sides. Sin 30. Sin 30. Okay, half into 15. Sin 30 half. Sin 30 value half. Now 15 over 4. 3.75. 3.75 square meter. 3.75 square meter. Are you clear? Okay, second example. Second example. Sorry. Okay, calculate this area. The area of this triangle. Okay, take only 1 minute. Now I am going to start our new lesson. Fatima, what is the answer? Yes. Okay. Others, only two answers. Okay, good. Okay, great. Okay, what is the equation? Half AB sine C. Any type of triangle, if it is right angle or any type of triangle, you can use the same equation. Half into AB sine C. Half AB sine C. Always C is the angle between AB. That's the condition. C is the angle between AB. Okay, now this is 8. It is 5. Can you find the side? Can you use Pythagoras theorem? Yes or no? Can we use Pythagoras theorem? Can we use Pythagoras theorem? No, it is not a right angle triangle because 60 and 80, no right angle, no 90-degree angle. We can't use Pythagoras. Okay, but we can find this angle. No? We can find this angle. It is 80, this is 60. Then I told that theta 1 plus theta 2 plus theta 3, it's 180. The summation of internal angles of triangle, any type of triangle. Then 80 plus 60, what is the angle? 80 plus 60, 140. 140. Then the remaining one is 40 because the total 180, it's 40 degree. 40 degree. 40 degree. Now 60 plus 40 is 100. 100 plus 80, it's 180. Okay, now half AB, two sides between the angle 8 and 5. 8 into 5 into sine 40. Okay, what is the value for sine 40? Can you get in remember? No, you have to use calculator. You have to use calculator. Sine 40. Okay, methana cancel out into 4. Now 4 into 5 it's 20. 20 sine 40. You can count. You can type on the calculator. I don't have sine cosine. It's 12 point value. 12.8. Correct? 12.8. 12.8 square centimeter. Okay, I think you are clear. Any doubt in trigonometry, you can ask now. We have only 3 minutes for this lesson. 9:30, I am going to start our new lesson. Yeah, round off, it's 12.86 near. 12.86, yes. 86, correct? 86, yes. If you round off, it's 12.9. Okay, you can use this form. 86. Okay, any doubt in trigonometry? Now, fully we discussed all parts, even circular bases also. Actually, they don't need for us. They need for pure math students, what we discussed for additional knowledge. And we discussed all relationships. In your syllabus relationships, only 2 relationships, but I explained all relationships. On all 5 relationships I explained. Yeah, more than syllabus, we discussed trigonometry lesson actually. Okay, I think now you have full idea and full knowledge about trigonometry. Any question you can face. Okay, you have homework. Are you complete this? Have we discussed trigonometry tutorial? No, ne? You may. Trigonometry tutorial not discussed. No. Few questions we discussed, as I remember. Two questions karane. We discussed only 2 questions as I remember. Yes. Okay, you have 10 more questions. You have 10 more questions. Okay, question number 12, very important. Okay, let's try to get question number 12. Okay, let's do question number 12 and 13. Then you have 8 questions for homework. 8 question. I will send you the answer sheet, answer numbers, then you can check. Okay, that's all trigonometry. They are very simple questions. If you have any doubt, you can ask. Yeah, that I have sent it 2 weeks ago. I complete this. Okay, however, this week homework, complete remain question, and now try question number 12. Okay, send the answer for question number 12. Sine 150 equals sine 30. No. That's the assumption. Sine 150 equals sine 30. Then the value of sine x is equal to. That's base of circular basis. No? Circular basis related question. But circular basis full knowledge you don't need for this question. Simple question. Okay, what is the answer? Sine 150 equal to sine 30. The value of sine x equal to. Habib, Fatima, what's the answer? Sine 150 equal to sine 30. Then the value of sine x equal to. Sine x equals sine 150, sine x equal 180 minus x, sine 180 equal sine 150 into sine 30, sine x equals sine 30, sine x equals sine x, 180 minus sine x. What you think? You met? Don't think about answer numbers. Answer number change. It's 2, 3, 4, 5. Yes. Yes, very good. All are correct. Okay, how to get this? That's very simple relationships, right? Now, they given a hint. Sine 150 equals sine 30. Sine 150, that we already discussed, right? Sine 150 equal sine 180 minus 30. No? Sine 150 equals sine 180 minus 30. Now this is sine. Sine mean not changing. Sine 180, sorry, sine 180. Sine 180 mean 19 to 2. Remember in circular base lesson? 19 to 2. Then it is even. It is even. Even never changing or not? Not changing, right? Then sine 150 equal to sine 30, no? Sine 150 equals sine 30. They are the knowledge. They are model paper questions. Model paper questions. That's why I explained everything. Now you can understand any trigonometry question. හරිද අපි භාගයට කරොත් සමහර ඒවා තේරෙන්නේ නැති වෙන්න පුළුවන්. Now you have full idea how to equal sine 150 into sine 30. I have explained. Now sine 150 equal sine 180 minus 30. Same thing. Sine 180 minus 30 is sine 150. 180 වලින් 30 reduce කරාම it is 150. Now මෙතන sine 180 mean 19 to 2. 19 to 2. 19 to 2 is the multiplication is a even value. Even values now sign is not changing. Sign is not changing. Sign same. Sign may value again. Sign 30 equal to sign 150. If you don't know circular based lesson, you can understand this. Please go through this if you not covered this part. Last week lesson, last day lesson. Okay, I got this point. Anyone? Sadhu? Clear? We change whenever, not whenever, changing, not changing things we discussed last day. Okay. Okay, now the question is sin x, no? Sin x. Sin x. Sin x equal. Sin x equal. Sin according to given relationship, sin 180 minus x. 180 minus x. This is the answer. Sin 180 minus x. Sin 180 minus x. Again, same thing. Sin 180 minus x equal to sin x because sin 180, no? 19 to 2, even. Therefore, not changing. Sin. Again, x value. Okay, answer number 2. Okay, question number 30. Question number 30. If cos 90 minus a equals sin a. Yeah, that we discussed, no? I explained all relationships. Cos 90 minus a equals sin a. That we discussed. Sin 90 minus a equal cos a. Then what is the value for tan 90 minus a? That's a theory point. What's the value for tan 90 minus a? Tan 90 minus a. Tan 90 minus a. You know? Sin 90 minus a equal cos a. Cos 90 minus a equal sin a. Their relationship. Then what is the value for tan 90 minus a? Tan 90 minus a. Tan 90 minus a. Sadev? Vihanga? Tan 90 minus a. Yes, that is a final relationship, no? Final relationships. I told sin 90 minus a equal cos a, cos 90 minus a equal sin a, tan 90 minus a equal tan 90 minus a equal to 1 over tan a. 1 over tan a, answer 3. Okay, tell me 1 over tan a venuවට instead of 1 over tan a, tell me another term. Equal another term. 1 over tan a venuවට. Very good to me. Fatima? Another term? Yes, very good. We can say it is cot A, no? Cot A. Cot A. 1 over tan A equal to cot A. Cot A. Okay, answer 1 over tan A. Okay, I think remember this relationships. That's enough. Okay, what are the relationships we discussed? That's a summary of the trigonometry lesson. It is not a theory lesson. What is our first relationship? What is the first relationship? Sine A over cos A equal to tan A, right? What is our second relationship? Sine squared A plus cos squared A equal to 1. This is the second one. What is our third one? Sine 90 minus A equal to cos A. Fourth one, cos 90 minus A equal to sine A. What is the final one? Tan 90 minus A equal to 1 over tan A or cot A. Cot anyway, cot A. Cot A. Cot A. Okay, that's a summary. This is a summary. Okay, what are the trigonometric ratios? We discussed 6 main trigonometric ratios. Sine, cos, tan, and cosec, sec, and cot. What is the relationship? Sine equal 1 over cosec. Think it is sine A equal. Sine A equal 1 over cosec A. If you got cos A equal 1 over sec A. Again, the cosec mean sine reciprocation, opposite direction. Tan A equal 1 over cot A. Tan A equal 1 over cot A. If you want, we can change this, right? Cot A equal 1 over tan A. Sin A equal 1 over cosec A. Cosec A equal 1 over sin A. Both say correct. Okay, any doubt? That's all about trigonometry. Any doubt you can ask. Okay, now 41. We got additional 10 minutes. Okay, let's start our new lesson. Okay, how many lessons completed up to now? First, we discussed measurement. Now, our first lesson, area and volume. Area and volume. Our second lesson, we discussed measurements. Third one, forces. Fourth one, rotational motion. Or angular motions. Fifth one, trigonometry. Okay, that's all. 5 lessons completed. 5 lessons completed. Five lessons completed, but we have another 20 lessons. 5 lessons done. Same, not actually same, more than bulk this level. We have another 20 lessons. 20 lessons. Okay. Get your tute, and if you don't have tute, open your PDF. Write down the, no need to write down our first topic, our sixth lesson. Actually, this is lesson number 6. Lesson number 6, work, energy, and power. Work, energy, and power. Work, energy, and power. Work, energy, and power. Okay, next lesson, we're doing our 4th lesson. This is a huge lesson that we called work, sorry, cell structure. Cell structure lesson is the most bulk lesson in our syllabus. Yeah, this is a cell structure tute. Tute එකේම තියෙනවා අපිට yeah 85 pages. This is a cell structure tute. Okay, next, within January we can complete the work, energy, and power. Every works with questions. I hope to start next month, first week, this lesson, work, energy, and power. Not work, energy, cell structure, sorry, cell structure. Okay, work, energy, and power. Get your tute. Yeah, it's a very simple lesson actually. We discussed about work, energy, and power, and relevant theories. Theories that about in this lesson we're going to discuss energy conservation law and mechanical energy conservation law. Okay, actually our target of this lesson cover all parts of works and understand all theories related to work and energy and power. That's all. Very simple lesson. Simple lesson, but you have two theorems to understand. Okay, first come to first page. The first topic, word, work. Work. Okay, what's the meaning of the work? What's the definition of the work? What's the definition of the work? What do you think? What's the meaning of work? Work. What's the definition of work? There's question from this part is coming full type essay questions or as subparts. Sometimes both versions coming in exam. If you refer past papers, full essay questions ඇවිල්ලත් තියෙනවා. Essay part එකේ no any question sometime. Some years only MCQ questions. That depend. Okay, work. Okay, work is a measure of energy transfer that occurs when a force cause displaced of an object. Okay, simply the work is think this is an object on any surface. This is an object. Think I applied F force and displace into force direction, displace up to this point. Displace up to this point. Displace up to this point. Okay, that the moving distance we called as displacement, right? Shortest distance. Shortest distance, displacement. Okay, for this movement, the energy transformation or energy requirement we called as the work. Energy transformation actually. The energy transformation, the work is a measure of energy transfer. Measure about energy transfer. Measure of energy transfer that when a force cause a displace of an object. Okay, force due to force applied, the object is displaced. For that process, the energy transformation measure we called as a work. Okay, what is a work equation? How to calculate this work? The work equal applied force multiplied by displacement into force direction. Your O-level time definition is not now correct. Your O-level time, what you use in O-level time, work equal force into distance, no? Force is displacement. This is not correct now. Work equal force into displacement into force direction. That's very important. Into force direction. Force direction and displacement direction should be same. That's a condition. The work equal force into displacement into force direction. Force direction. Now see, this is a force direction. This is applied force direction. This is the displacement direction. See, this is so same. Force direction and displacement direction same. If it is same, this applied force multiplied by displacement, you can get the work. The work is the energy transfer. Energy transfer measure to displace some object by applying force. Okay, what is the definition? The energy transfer measure. You can make a simply definition with these three terms. the energy transfer මේ විදිහට ලියන්න ඕනේ. හරිද? These three terms are very important. The energy transfer measure to displace an object by applying a force. Force එකක් apply කරලා displacement එකක් කරද්දී energy transform measure we called as measure of energy transform we called as work. Okay, in short form we can say this work capital W. This is a symbol for work. Work equal capital W. Force capital F. Displacement simple D. Simple D. Work equal F into D. Okay, this is the equation. This is the equation. This is the equation. Okay, what do you think? What is the unit of work? What is the unit of the work? What is the unit of the work? What's the unit of the work? Yes. Very good. Very good. If you got the according to equation, it's Newton meter, right? But Newton meter is not the standard unit. Not the standard unit. This force, the work is special. The work is special. Work is special. But now see, the work is energy transformation measure. Then what is the unit of any type of energy? Energy unit is joule. Remember, SI unit, standard unit of work, it is joule. Joule is the standard unit. Joules is the standard unit. Joules is the standard unit. Okay, if you want, you can make a short note. I can give you 1 minute. Everything given in the tube, no? Yes, everything given. A unit not given. You can write, note down unit. Okay, writing. While writing, think work is vector scale. Think according to definition and equation, you can think is work vector scale. What do you think? It is a physical quantity, no? Work is a physical quantity. Is it physical vector quantity or scalar quantity? What do you think? vector scale. Yeah, I explained in final tutorial discussion of paper discussion. I can't remember. Anyway, I explained. Yeah. Yes. Now, Vihanger. Work is a scalar quantity. Yeah, that's a special case in physics. But the problem, it has a magnitude, no? It has a magnitude as well as displacement direction. But what is the meaning of the work? The meaning, the definition of the work, not force into displacement. The multiplication, not multiplication of force into displacement, that's a calculation method. What is the definition? The energy transfer. In a measure of energy transfer, then energy transfer, is there any direction? We can't get exact direction. But our calculation, we can say right side direction or left side direction. Or no direction like this. But energy transformation, energy is a scalar quantity. Energy is a scalar quantity. Therefore, remember, work also, special case, scalar quantity. Work is a scalar quantity. Work is a scalar quantity. Then energy කොහොමත් scale. Don't have direction. Don't have direction. Okay. Especially note down this in the tune. The work is scalar quantity. Work is a scalar quantity. Okay, I will explain in the power part. Power, what do you think? Power, scalar or vector? Energy and work, both scales. Power, power also scalar. මේ තුනම scalars. Work, energy and power, all are scales. Remember, okay. Okay, simple. Okay. Okay, right. Get your notebook and write down the topic. Work exercise. Work, energy and power, lesson number 6. And write down subtopic. Work exercise or examples. Work exercise. Write down a 3 kilogram object . on a horizontal surface is displaced 75 centimeter due to applied 20 Newton external force. Calculate the work done by the object. Calculate the work done by the object. Calculate the work done by the object. 3 kilogram object. 3 kilogram object due to this 20 Newton applied horizontal force. It's moving 75 centimeter distance. 75 centimeter distance on the horizontal surface, ground surface. What is the work done by the object? What is the work done by the object? Okay, calculate quickly. Take only 1 minute. Calculate. Okay, complete. Yes. F into D. What is applied force? 20 Newton. 20 Newton. Force into displacement to same direction, right? Displace into force direction. Now displacement direction and force direction same. It is 75 centimeter. 75 centimeter. You can't use, you can substitute in centimeters, convert into meter. 20, 0 to 0 cancel. It's 2 into 2 divide 5. 75 divided by 5, answer 15 joules. 15 joules, not Newton meter, 15 joules. 15 joules. 15 joules. Okay, example number 2. Example number 2. Example number 2. Okay, write down. A grass cutting machine is operating by apply 500 Newton. 500 Newton external force on handle. The angle of elevation of handle to the ground level, to the surface, 60 degree. 60 degree. Write down. Calculate the work done by the machine. Work done by the machine while moving 10-meter distance 10-meter distance on the ground surface. On the ground surface. Okay, this is a story. Clearly read question and understand and try this question. Okay, the point, the equation is the point. What is the equation? The work equal force into displacement into force direction. Now this is the force direction. This is a force direction. It's an elevation. This is a force direction, but the machine is moving in this direction. මෙහෙට තමයි මෙයා moving on the surface. Okay, calculate the work done by the machine. Okay, I'll give you 1.5 minutes. The grass cutting machine is operating by applying 500 Newton external force on the handle. The angle of elevation of handle to the surface is 60 degree. Calculate the work done by the machine while moving 10-meter distance on the ground surface. Ten meter is the displacement. 10 meter is the displacement. Ten meters. 500 Newton force. Vihaga? 500 Newton force. Others? Only 3 answers. Fatima? Yes. Now, yes, what is the equation? The work equal force into displacement into force direction. The condition, the displacement direction and applied force direction should be same. That's a condition. Okay, but now displacement is different. Force direction is another one. Okay, now can we change the displacement direction? We can't change displacement direction because it is moving direction. But we can we can find the component of the force into the displacement direction, right? That's why we discussed in the force lesson the force resolution. You can use this force resolution for the calculate the force component acting on displacement direction. Okay, now we already know 500 we can resolve it into angle direction. Angle direction we can resolve by 500 cos 60. 500 cos 60. Now this angle direction, sorry, this displaced direction, the 500 cos 30, no 60. 500 cos 60. 500 cos 60. Okay, now the force is equal 500 cos 60 into What is the displacement? 10 meters. 10 meters distance. 500 cos 60, cos 60 value half. Then 500 into half, it is 250. 10. The answer 2500 joules. 2500 joules. Okay, correct. Oh, okay, question number 3. Exercise number 3. Exercise number 3. Okay, this is the diagram. $30 kilogram box is lifting 5-meter height stage as given in the figure above. Calculate the minimum work. Calculate the minimum work required for above process. Okay, calculate the minimum work is asking, right? The minimum work is asked. The minimum work. Minimum work. The minimum work. Okay, send your answers. The minimum work required for lift this box. Fatima, what's the minimum work requirement? What's the minimum work requirement? Yes. The question asks minimum work, right? The question asks minimum work. Yes, very good. Minimum work. Okay, if you know the force equilibrium or Newton's law, what is the minimum force required? What is the weight of this object? The weight of this object, 30 kilogram, 300 Newton is the weight. 300 Newton. If it is 300 Newton, what is the minimum force required for lift this object? If there are no any air resistance or no any other disturbance, if I apply 300 Newton into upward, it's lifting. It's moving uniform velocity, right? According to Newton's first law. If there are no any resistance, air resistance, normally in normal condition, actual practically, we can't do this in our normal environment due to air resistance and other disturbance. But theoretically, this is a minimum force requirement. This is a minimum force requirement. Okay, now we can calculate the minimum work. The work equal F into D now. F into D. Now force applied direction and displacement direction same. Displacement direction same. Now 300 Newton displacement into 5 meter. 1500 joule is answer. 1500 joule is answer. 1500 joule is answer. Final question. Final question. Final question. €10,000. Okay, write down the question. 500 kilogram container box. Container box is lifting by a cable, by a cable 600-degree angle to the horizontal level. If 10,000 Newton force applied on the cable, if 10,000 Newton force applied on the cable, calculate the crane. Crane mean make a the machine. Okay, calculate the calculate the work requirement. Calculate the work requirement for up to 20-meter height. Okay, this is a question. Calculate the, if 10,000 Newton force applied on the cable, calculate the work requirement for lift up to 20-meter height. 20-meter height. Then displacement 20 meter. 20 meter එක තමයි යන්නේ. Think it is 20 meter. Okay, quickly write down the question and get 2 minutes for this question. It's 20 meter. Get only 2 minutes. Now 10:30. Send your answers. 100,000. Are you sure? It's not this direction. Not a vehicle. It's a container box. Vehicle? Yes. Very good. Sandeep? Sandeep? Yes. Good. Correct. Okay. Now work equal F into D, right? Now this is the lifting direction. මෙහෙට තමා lift end. This is a 20 meter. But force applied to this direction. Normally in practically force applied to this direction by cranes. අපි crane එකකින් මෙහෙම තමා force එක apply කරන්නේ. By using cable, right? Now, but force direction and displacement direction not same. Now you can resolve this 10,000 Newton into vertical direction. Don't need to horizontal direction because it is moving in vertical. Okay, now 10,000 resolved into this direction. Now what is the force? 10,000 sine 60 because opposite side from the angle. This is 10,000 cos 60. This direction it is sine 60. Displacement 20 meter. 20 meter. 10,000 sine 60. 10,000 sine 60 root 3 over 2. Root 3 over 2. 20. 5,000 root 3. 5,000 root 3 into 20. 5,000 root 3 into 20. The value 173,000. 173,205. 173,205.08 joules. Okay, any doubt? Any doubts? Okay, now next week we can go for combined questions. Okay, if this same question asks what is the acceleration of this object? What is the acceleration of this object? What's the acceleration of this object? What's the acceleration of this object? Then make up your one. It's lifting. What is the acceleration of this object? Any idea? Habib? Okay, today our target understand work. No? Okay, this type combined questions coming in exam. Not only work. Okay, no. How can calculate normally 10,000 into downward? What is the force? What is the force into downward? 5,000 Newton, no? Because 500 kilogram weight 5,000 Newton. Into upward, what is the force? Upward, this yellow color line, what is the force? Kabir, what is this value? 10,000 root 3. Root 3 over 2. 5,000 root 3, what is the value? 5,000 into root 3, what is the value? 5,000 multiplied by root 3. 8,660, correct? 8,660. Now can you understand into downward 5,000 into upward 8,660. Now is it balanced system or unbalanced? Completely unbalanced. It's accelerate to upward direction. But in previous question, 300, 300. Now it is balanced. Now it is no acceleration. No acceleration. It is moving in uniform velocity. Okay, that's force lesson. If there are no any unbalanced force, it's moving in uniform velocity. But if it now this time it has an acceleration, right? This time it has acceleration. How to calculate this acceleration? Okay, next week I hope to do. I hope to calculate combined questions. Today our target understand work. Okay, how to get? What is the method? Newton's second law, right? Simple. Newton's second law. Now, what is the resultant force? The resultant force upward direction 3,660. Resultant force into upward direction. 3,660 resultant force into upward direction. Now F equal ma. F equal ma. F 3,660 resultant force. F equal ma equation. What is the value? What is the name of F? Resultant force, not force. Not force. M 500 into A. අපිට ඒ ගන්න පුළුවන්. 366 over 50 is the A. Approximately 7 නේ. 7 point value. Okay. No need. Just 7.3. Yes. Okay. For this question, no need. But in exam question, always combine question coming with force lesson. And our next lesson, mechanical properties of matters, add කරලා තමයි combine questions. Okay. Yes, that we discussed when force is at an angle, we can resolute our force into displacement direction. The given force we can resolute into displaced direction, and F cos theta or W equal F d sin theta, that depend on the side. That depend on the angle given side. Cos theta or sin theta, both we can use. Okay. Yeah, that is explained about this. And SI unit is joules. It is given. SI unit is joule, and work is not a vector quantity, it is scalar. Write down work is a scalar quantity. Work is a scalar quantity. Scalar quantity. Okay. Now, do you remember in first lesson, we can define what's the meaning of one Newton. Actually, these Newton, joules, they are Pascal and what else? Ampere. They are not actual units. They are derived units. Why we call they as derived unit? ඒවා අපි හදාගනිපුවා. For with this scientist name, Newton mean Isaac Newton name. Joule also same. Ampere, watt, volt. They are scientist names. Part of scientist names. Okay. Therefore they not actual units. Okay. Therefore, do you remember in force lesson, according to Newton's second law, F equal ma? This is the equation. Do you remember in force lesson 1 Newton? How to explain 1 Newton? How to explain 1 Newton? First Newton. What's the definition of 1 Newton? That was exam question. How to define 1 Newton? Very good. The amount of unbalanced force required, no need to by heart, okay? No need to by heart. You can remember by equation. The amount of unbalanced force. This is unbalanced force. The amount of unbalanced or resultant force required to accelerate 1 kilogram object to accelerate with 1 ms minus 2 acceleration. This is the 1 Newton, the required unbalanced force. If that we called as the 1 Newton. Yes, the amount of unbalanced force required or resultant force required to accelerate 1 kilogram object with 1 ms minus 2 acceleration. That is a 1 Newton definition that is given in the first lesson. Okay, samely, what is a 1 joule definition? 1 joule also same. Same definition. මේ දෙකම exam එකේ අහලා තියෙනවා. Both was past exam questions. What's the definition of 1 Newton? What's the definition of 1 joule? Okay, how we can define the 1 joule? Joule equation, work equal FD. Okay, samely you can make a definition. හදන්න බලන්න. Without reading tute, make a definition. This is the work. Yes, very good, Kabir. Yes, this is a P6. P6 is not a definition by heart or concept by heart. It is not a subject. Okay, it's simply relationships and rational subject. By heart, you can't by heart. Other answers? What's the, now I told what is the definition of 1 Newton. Same method can you can make a definition for 1 joule. Yes, very good. The work done by any object, the work done by any object by apply 1 Newton force and displace 1 meter. 1 meter displacement and 1 meter displacement get by apply 1 Newton force. During this process, work done we called as a 1 joule. That is a 1 joule. Okay, this is a definition. 1 joule is defined as a work done when a force of 1 Newton, force of 1 Newton displace an object 1 meter distance, direction of same force, direction of the force direction. Okay, that's the full definition. The 1 joule is the work done when a force of 1 Newton displaces an object of 1 meter in the direction of force, into same direction, right? Then 1 joule equal 1 Newton into 1 meter. This is the mean. This is the mean. Okay, draw a diagram here. මෙතන ඇඳලා තියන්න. 1 Newton force, by apply 1 Newton force when this same object displaced 1 meter displacement, 1 meter distance, the work done by the object. The work done by the object. This is the 1 joule. Okay. Diagram එකක් හඳි. Okay, that's the end of work part. That's the end of work. Next week, we're going to start our energy part. Very important energy part. Energy part is the most important part of the lesson. Energy. In energy part, I'm going to discuss different energy types: light energy, sound energy, electrical energy, nuclear energy, magnetic energy, and mainly the main part of this lesson, mechanical energy. See, mechanical energy is the main part. Mechanical energy. Every concept in mechanical energy going to discuss in this lesson. Mechanical energy. The most important part of this lesson, energy, and power and efficiency parts are easy. Power and efficiency, the final part is easy. Yeah, they are energy, up to now energy. Yeah, power and efficiency, they are very simple parts. Yeah, this is our tutorial. Yeah, tutorial question also given in the final page of the paper. Okay, are you clear up to now? The work is completed. Are you any doubt up to now? No, understood everything? Okay, today homework, complete this tutorial, previous lesson, trigonometry tutorial. trigonometry tutorial. And again, go to work and ready for the energy lesson next week. Energy. Yeah, the most important part is energy. Okay. Okay, that's the end of the today class. Let's meet on next week with energy lesson. Goodbye.